All right, it is 9 o'clock, so I'm gonna get started, and we can kind of figure this out as we go along. So real quick, before we begin, I'm gonna be going at a pretty quick pace for this. So if anybody has any questions, or if I don't go over something in enough detail, please drop something in the chat, ask a question, and I'll try and answer the questions as I go along. So that way nobody kind of gets left behind and we can kind of like keep up the pace for the whole thing. So welcome to my presentation. This is how to build a full stack application in 1 hour, going from your idea to actually deploying it in Google App Engine and have it publicly accessible for everybody. So a little bit of information, who am I? So my name is Jake Sylvia. I'm a software engineer at Addigy, and I was one of the first members hired. I was the sixth or the seventh person brought on the team when we were still like, a small baby company. And over the last 3 years, we've grown like crazy. And now we have almost 100 people on the team. So we've had a lot of growing pains over those years, trying to go from, what I talked about in the beginning, throwing a bunch of code together really fast, trying to get it working. And then we get to scale and we're like, we got to rewrite a bunch of this stuff because this isn't like feasible to scale well. Other than that, I was a instructor for the University of Miami at the Web Development Bootcamp. I'm a co-founder for Rock Esports, and I have about 5 years plus of enterprise level production experience. So moving on to the idea for our actual application, right? So a little bit about me. I use OfferUp all the time. Like all the time. I love buying things on there, looking for the best deals, flipping things, doing all that stuff. So what I have is an OfferUp bot that scrapes OfferUp and it just puts all the information into a CSV file, right? Just so I can kind of like look through it and I can kind of do some programming on it. But what I've come to realize is that a lot of people tend to use this. So this might benefit a lot of other people if I can start setting up a notification system so they can sign up for this application. So what I want to have happen is I'm already going to have the OfferUp database, right? And I want users to be able to go into the application and easily sign up based off of a search query and some like search parameters, and be able to get email notifications and possibly text notifications for whatever they pass through. I want this to be hosted in Google App Engine, and I want this to integrate with Google Sheets so that way I can start running like analytics, start doing some charts. I can start doing like metrics for price monitoring, a lot of cool stuff. I actually sold something on OfferUp like 3 days. Yeah, I'm on OfferUp like all the time. So what do we want to have happen for this, right? I want to develop this with the expectation that there are going to be more people hopping onto this team, right? And this is going to grow exponentially, so this has to do well at scale. So I want automated deployment. I want a simple deployment process that I don't have to run a bunch of commands and do a bunch of different things, go into a bunch of servers just to deploy my new version, because that would be a huge pain. I need this to be secure because there's going to be a lot of API tokens sent back and forth, private keys, all kinds of stuff with Google Cloud. It has to be maintainable. So if I'm bringing people on the team, or I'm developing new features, or there are bugs in the system, I need to be able to fix those as easy as possible, right? I need this to perform well at scale with a large team, okay? I need this to be easy to read, so as people come in, it's easier to read. And even for myself, as I'm going through the code, I want to be able to know exactly where something is being done without having to put too much thought into it. And it needs to be flexible, okay? As in terms of like the features it can support and databasing and all that kind of stuff. So we're going to be using Go and Vue, right? So a lot of people have heard of Go, but for those who haven't learned about it, it's Google's backend infrastructure language that they developed in-house and then open sourced it for the rest of the world for them to be able to use. And they built it specifically to be a high-performing, easily maintainable API service that ended up going into executables, OS level development, and all kinds of different stuff. So the benefits of Go is it's incredibly efficient and insanely lightweight, okay? So it has a garbage collection system. So if there's any sort of error throughout the entire application, you cannot compile and it'll throw an error on compilation, right? It's multi-threading, which is really, really important for an HTTP server, is the best in any language, right? So for every thread of programming that you end up using for Python, let's say, because Python is a very large, widely used API service, right? Or API language. Each thread of memory, each request costs 1 megabyte of memory, right? Now that might not sound like much, but when you start getting to scale, you put this in a server and you start servicing thousands and thousands of requests. You are spending a lot on memory to keep those requests efficient. Now with Go, those threads are 2 kilobytes, okay? So if you have 1,000 threads running on Python, you will get 5,000 on Go. It's ridiculous. So it's extremely flexible. It has a huge built-in library. The dependency management is really nice. So if I include any external libraries, when I compile it, it reads all the code that it's using and only compiles the code from the libraries that it's using, and it'll throw away the rest of the code that is not being used. So when you compile that down to a binary, it's a very, very tiny binary. It's made to have the readability of Python while still being a typed language that's just as powerful, in some cases a lot more powerful than Java, right? So you kind of get the best of Python and the best of Java, one language, and it's amazing. Now why Vue, right? So Vue is where I have most of my experience in. I've worked a little bit in React and I've worked in Angular before. And so far Vue is my favorite because it's the easiest to read, it's incredibly efficient. Its state management and data reactivity is really, really easy to understand and be able to, develop applications without having to worry about passing data through the pipeline and having to re-render a bunch of components, because a lot of components in Vue does that automatically. Okay, so to give you an example of how fast Go can be, this is a speed test run by doing 5,000 concurrent connections with, I said in here 1,000 requests per connection. Oh no, it's requests per concurrency, right? So in PHP, it can make between 5 and 1,000 requests per 5,000 connections. But Go, you can see compared to Java and Node right here, Go can make a little over 4,500 requests with 5,000 concurrent connections. This isn't even including the memory that's required to run these, which again, the other besides maybe Java would just this chart would be ridiculous. And if you had Python would be all the way down here in the hundreds probably. So this is my point across to, Go is really, really good for doing startup applications and scaling really, really easily. So this is why I choose this language over Node or Python or PHP for every single one of my projects, every single one. Okay, so let's start hopping into the code. So first off, we need to start doing our front end, right? So you might notice a lot of these files. Here, let me zoom in a little bit. There we go. Is that better to see? It's probably easier. So you might notice a lot of files on the left here, right? So this is all pre-templated information. This is all from the Vue initialization, as well as the bootstrap that I'm going to be using and all of that. So first thing we need to do is set up our front end. So inside of our source, right, we have our app.vue, and this is our, if you've done React or Angular, you have your root app, and that's what this is. This is just a bunch of setup from Vuefy and Bulma, which are our two front end libraries that we're going to be using for our custom bootstrap and our component library. Inside of our index, this is where we actually initialize our application, right? But there are a couple of things we got to do first. So inside of this router folder, you might know, or inside of this source folder, you might notice a couple of things. So we have our assets, which are obviously, custom images, custom CSS, that kind of stuff. Component library, we're not going to go into that. We have our requests, right? And this is where we define all of our requests. We'll get to that in a little bit. And we have our router. So first, we need to initialize our router. Okay, so let's do that right now. Let me pull this up. So this is all initialized by default from Vue using the Vue router library. So to define a new route for Vue is pretty straightforward. All we have to do is inside of this routes array, put a new object in there, declare our path, right? So first we have to set up our home path. Give it a name. So we'll give this name. We'll give this a name of home, and then we have to feed it a component. Okay. Now, we don't have our component yet. We're going to declare that now in the views folder. So inside of views, we have our subpath. We want to hold our index inside of our home folder. So that way we can separate each one of our views into a separate folder completely, because each folder for a specific route might have multiple subroutes where we could do multiple folders, or we can have multiple components or views inside of that one folder. So inside of our home, we have our index right here, and this is just a standard Vue component, and we'll throw some meat into this in a second. So going back to our router, we can import our home by going into the views and then the index. Let me see. Views and then home. There we go. And then this will reference our index, and then we can just attach that content right here, and bam. So we have our root, we've attached our component. That's easy. So we can close up our router right now. And inside of our index, this is where we need to start initializing the setup for the rest of the application. So first, we're going to import some of our default libraries. So this is Vuefire, our front-end component library. Our app, this is where we initialized Vuefire and Bulma. We initialize our router, and then we have our Ajax. So inside of this Ajax requests.requests, this is where we're going to be initializing all of our requests. We'll get to that in a second. Now we need to initialize of other things. So we'll say that we want to use Vuefire. We'll set the application. Oh, we don't need this. So what's really nice about Vue, one of the features that it gives you kind of out of the box is when you access the prototype, right? The any property denoted with a $sign is known as a global property, right? So if I declare $Ajax here and I set it equal to some object that I've declared or some method, I can reference that in any part of the front end. It could be inside of a component, any child component, any view. All I need to do is call this.ajax, and then I can access any of its methods. Okay. Okay, so moving on. So now we have this notification. This is a component from Vuefire. So anytime we want to show the user a message, this is what we can use. And it will have like a little drop down that says, error or success. We will establish the router, and then we'll add a renderer. So okay, so we're done with our index.js, and this is what does the setup behind the scenes besides the HTML in the app.vue. So now what we can do is we can go into the actual index and start putting some CSS in there. Okay, so first we're going to add a section. This just gives a little bit of padding on each side to kind of like bring it into frame a little bit more. We're going to put that in a container. And what that does is it centers our content horizontally. And now what we need to do is put in our title. Okay, so we're going to call this offer broker, give it the title class. This is all established through Bulma. So this is the CSS library or the Bootstrap library that we talked about before. Bulma is a very powerful and very popular front-end framework. So now that we have our title done, we're going to start adding the fields for what we need for the form, right? So what should we do first? We need to declare what kind of fields do we want. Is there any way you can make the fonts bigger? Oh, is it not zoomed in here? Oh, it was only on the one file. That was my bad. There we go. That's probably better. If you need me to zoom in more, just let me know. Okay, so we need to figure out what kind of data properties we want to pass in, right? So we're going to need an email. We're going to need a search. We're going to need a radius of how far it's going to be, the minimum price that you want to filter, and the maximum price that you want to have filtered. So let's establish all those right now. These can be, these three are optional. This is why we're setting this to null. These two are not optional. So that's why we need those. Next, we will start referencing these as fields. So first, we can do a column. Let's set up some columns. Anybody who has worked with Bootstrap before knows what columns are, except these are done a little differently. In Bulma, I can actually specify in English how big I want them to be. So we're going to need 3 columns. All right, so we'll have a column, and we'll do 2 of them as 1/5. Close that. Oops. And then we'll have the middle one as 3/5. Okay, so what that's going to do is divide it up into 5 columns, right, widthwise. We're going to just get rid of those 2 side columns and only have 3/5 of the center of the page for the actual content itself. And this is where we're going to start putting our fields. So in Vue5, we actually have access to this B field component, right? So we can set this as required. We'll give it some padding. This is padding bottom 3. And give it a label of 3. Add a placeholder. We'll give it the rounded property. Set the V model. Now this is how you bind. You do data binding in Vue. Okay. So you can see if I click on this, it highlights email down here. That's because this component now sees the email property being used, and we'll give it the type of email so that it does some like front end validation on its own. We'll declare another B field, give it the class of 3, and then this one, what do we want this to be? We'll have a label, and this will be the search label. So inside of this, we also want an input field, so we'll put that in here. For this example, we'll use iPhones because iPhones are extremely popular in OfferUp. We'll give it the rounded. We'll put the email or the email of the search. And we'll just get rid of this type because it's a standard B field. Okay, so what else do we need? We need a radius. So we'll copy this, change the labels, radius. We'll just put 20 as the placeholder, rounded, B model, and then we'll have this as radius, right? So one neat thing about Vue is if I want this to always be a number and pre-format it, I can just add the dot number right after V model. And it will always return as an integer instead of, it could return as a Boolean, it could return as a string, which JavaScript is known to, mess around with its types a little bit. So now that we have the radius, what we can do is add a grouped field, right? So now we have 2 other fields, right? Min price, max price. These will be grouped together. So what's going to happen is they're going to be on the same line, and they're just going to be right next to each other and touching, right? So that's going to make this a lot easier for the user to, see min price, max price, they're both together, and then I just have the one field. Set this to min price, max price, and we're good. So the last thing we need is a button, okay? So we'll give this a little bit more padding. We'll set these type to is primary since we want our primary colors to all match. We'll expand it so it'll take up the full width of the div that it's in. We'll give it a loading property. I'll go into that in a second. And then the click event will be for submitting. Okay, so there's a couple of things. I'll slow down here. So with loading, any dynamic property that a component can take is denoted with this loading state. Okay, and that's with the semicolon. So we'll copy this is loading. Put this down here and set that to false. That will get turn purple. It'll see it. Now, any kind of event is denoted with this @ sign. So every event in Vue can be denoted with this @ sign, and everything has an @click, @hover, different kinds of events. So now we need to actually define our submit method, right? So we'll come down here, and inside of our methods, we'll declare a submit method. But first, we need to have some kind of validation for if this actually fails and there's some bad input. Oops. Right here. So we'll check if this email is equal to empty or the search is equal to empty, and then we'll return back an error. Okay, so how we can actually handle that is by checking for it. We'll establish an error, set it to validate. If it is not equal to null and there is an error message in there, then we'll show a notification saying, please enter your email. Cool. Okay. Now that we have that done, we can set loading to true, declare our form object, and then we can start handling our request. But we haven't handled our request yet, so let's go do that. So inside of our requests, we use a package called Axios. That's Vue's built-in package for making requests. It's Ajax request. And this is a very important concept, using something like catching errors and returning back in a single object. Because for those that have used Ajax in the past, or just any kind of big scaled JavaScript, you know that callbacks get really lengthy and kind of difficult to read and hard to use sometimes, right? So by declaring a method like this, when we actually want to establish a post request, we can just return if we have a catch. If there's an error thrown, we can take that error, put that in our catch errors, and it will get returned inside of an object, right? So I'll show you how this actually works when we want to make that request. So let me go back here. So when we declared our global property, right? Remember we said we can just call the Ajax by calling this.$Ajax, and we can see that it has a submit form method. We'll use that, pass in our form, and then we'll do do our callback, pass our response. And all we have to do is check if response.error is not null, then that means that there is some kind of error. So we can use our notification component, set this to is danger. So it lets the user know that there's been an error, and we'll just return back this response error and return out of this request. If it's successful, then we will say thank you, and we'll send you an email. So you can see we only have one callback here. There's no two callbacks. It's much easier. Yes, I'll increase the font a little more. There we go. Is that better? I wish you could go full screen on this app. So now we showed the user some kind of message saying that it's been good, and now we have our front end finished, right? So this should be the entire page that we need. So now we can start moving on to the back end. Okay, now this is where things get a little crazy. So first, we're going to have to declare a package called server, and we're going to have to declare our main variable, right? Just like Python, if you see, I'll zoom in more so it's not, there we go. Just like Python, you need a main function and you need package main to establish this. We're not going to put anything inside here yet. First, we're going to go through and architect our whole backend, okay? But in order to do that, we need a couple of things, right? So if anybody's built a full stack application before, or been to a boot camp, have been trained, you know that you need some kind of models folder. I call them entities. And this is what holds all of your objects that you're going to be using to interact with the database, be it taking from the front end. These are your data objects, right? So, we're going to be taking a form here. So we want to have a file for each object that we're going to have, because each object is going to have a set of methods. And we don't want that to be one huge file, because down the road, if we have 100 objects, then it's going to be difficult to classify all of those. So by putting one file, one object, it makes it very easy to get to, very easy to read. So we'll have forms as our file, and we're going to describe that right now. Type form. There we go. This is how to create an object. Here we go. So first, we're going to need the actual properties. So in here, we're going to have search, email, radius, min price, and max price, right? And these JSON tags right here, these are what the key get automatically translated to anytime this hits JSON or detects JSON. So when we send our post request, if we say max underscore price and we want to translate that that object to our object, then it will translate using the max price, and it'll set it straight to the max price property. This makes it a little bit easier to actually reference the fields and still keep your JSON clean for API purposes. Because if you start having all kinds of different formatting, then it just makes it really difficult to read. So we're going to need a validation function. So how to declare a method in Go is you declare a function like any other. You give it a receiver. So in this case, it'll be form, and we'll call this validate. This is not going to take in any parameters, but it will return an error. So like on the front end, we only want to check for two fields that are required, and that's search and email. Okay. Now, you can return an error by using the FMT package, and this will return a string as type error. If we check both of these, if they're empty, we want to send that back and deny that request. We don't want that getting in our database. If it's not, then we'll return nil and we'll say, yeah, this is good. Even if radius, min price, and max price aren't there. But since we're going to be interacting with Google Sheets, there's something we need to think about a little bit, and that's with Google Sheets, when you get your data back from their API, they don't give it to you in objects, which would be nice, or a JSON object, which would also be nice. They give it to you in a two-dimensional array based off of your rows and columns, okay? So each row is its own object. So that means it's our job to translate that array for each row into an object, okay? So that means that we need to do that translation somewhere, right? But should we do that in our endpoint? Should we do that on the front end? Like, how should we do that? So, like, there's a couple of ways you could do this. You could just keep everything as a string, but that will cause problems if you want to start doing logic based off of radius is bigger than the radius that they have set previously, or you want to start setting min price, max price checking. It just gets really messy. So you could translate those individually whenever you need them, but that starts getting really messy, hard to read, and unmaintainable, which is what we're trying to avoid. So the best way to do this is if we have our database, we have our API, as soon as that data is about to hit the database, that's when we translate it to a list of strings, right? And the same vice versa. If we're going to be getting that from the database, as soon as we get that object, we want to convert that to a form object, right? We don't want to return a list of strings because that would just be a nightmare to deal with. So that means we need two methods. We need to be able to convert this object to a list, and we're going to have to create translate a list of strings to a form. Okay, so there we go. So when we call the form to list method, it will just format all of our fields that we just declared into a list of strings, so that way we can insert that into the database. And if we get that, we can initialize a form object, pass in a list of strings that we got from the database, and just set the object accordingly, right? So now we have our form entity, right? So we can move on from that. We'll close this, and now we'll start moving on to our settings, right? So this is very important, and this is where you start to get to security, okay? So what the settings are is a list of API tokens, ports that you want to listen to, sensitive data that you use throughout your application that you should not ever have hard-coded, right? Under very, very special circumstances. So you might be asking, why can't I just hard-code it? I'm the only one that's going to be seeing it. But if anybody were to get access to your project, somehow your API keys would be right there. The keys of the kingdom are all like in plain text, ready for anybody to take, okay? Now, it might sound a little difficult at first to kind of go against that, but it's actually a lot easier than you think. So if you have, a bunch of environment variables where you store all of your keys, all you have to do is get them from your environment, attach them into a global property, and then just reference them throughout the platform. Now, when it comes to deployment, that's when you have to have some sort of deployment script to insert those private keys and those environment variables. Okay. So now that we have our settings set up, we can close that, close this, close our forms. And next we are going to implement our store, right? So what is a store? In other words, it's a data store. And this is where the flexibility and maintainability starts to take shape, right? So in Go, one of the greatest features that it provides is it's called an interface, right? So it's different from an object, and it's not like, it doesn't have its own methods or anything. It's essentially a blueprint for any kind of object that meets a criteria of a list of methods, right? So that might sound like Japanese, but this will make a little bit more sense here in a second. So if I know that when I'm going to be declaring my data store, which in this case it's Google Sheets, I want to have the option to be able to switch to MySQL, SQLite, MongoDB. I want to have that option without having to rewrite my entire application to be able to hold that, right? So I know for a fact that this application is going to need two methods, right? And that's to be able to get the forms from the database and save the forms, okay? Now, these are always going to stay the same, no matter what the implementation is, whether it's Google Sheets, Mongo, MySQL, they should all have a get forms method that doesn't take anything. And all it does is it gives me the forms, the form objects, and returns an error. And that's it. That's all a store should be, okay? Now, you might be thinking, like, there's no implementation of this. How do I actually use that? Well, we can declare that a little bit later. So first, we're going to go into our endpoints, right? So we're going to create a new folder, and we're going to call this endpoints. This is going to hold our categories of endpoints as well as our context, right? So we'll name this server context. So a lot of people get confused with what context is, and it's essentially an object that holds a predetermined amount of information and methods that you can use throughout the request as you pass the context down the different levels, right? So it's used primarily for logging, tracking where a context has been. But the most useful thing with developing is actually attaching the data properties like email, auth token, and then a list of methods. So in this case, we're going to need a store with the method that we just created in our context, so we can reference that data store at any point in our endpoint, okay? So what does a context look like? Well, this is what a context looks like. So it has a core context, right? And this is with the context package, context. And this will implement our store interface. Okay, store interface, right? So now that we have our store interface, we can actually declare our server context, right? Because this is where the server context gets initialized, is in the middleware, okay? So init server context, we're not going to put anything. Well, we'll set the properties for the context in the beginning, and then we'll just say we want to call next. Okay. We're just going to assume that store is going to be there for now, and we'll create it later. So now we can actually get to the fun part, which is actually making our first endpoint. Sweet. So we'll call this endpoint for now. What does this endpoint going to take? This is, first we're going to do our submit form. So this is definitely going to be a post request. And we'll call this submit form, right? This is going to take in the variables that we just declared in here. We'll call, it needs to take in the context, and the context is always the first parameter. So we'll call it server context and then paste in our two other parameters. You don't have to worry about passing these in. These are passed in by default from the middleware, okay? So now we need to get the form, okay? So what do we need to do first? So we need to declare our form object, right? Because this is going to be submitting one form. So we'll call it form, create a new form from our entities. Okay. And then we need to actually reference the body and marshal it into the form. Okay. So I know that returns an error. We'll call this JSON, a new decoder, body, and then we will decode it. Oops. Decode into form. All right. So what this does is, you know, a bunch of Go types are being handled here. So the body is a byte reader. The decoder reads those bytes and then writes those bytes into the form object that we just created. Now, since we're using the JSON package, these JSON tags that we have right here, we will be the reference point for when you send the body. Oh, fine. Thanks for reminding me. I keep forgetting. Keep clicking around and the fonts. I can't believe they don't change. It's kind of weird from this IDE. So, okay, so we have an error. How do we want to handle this error? We can't throw this error away because this might contain something. This might be bad data. It can be something useful. So we'll do if error is not equal to nil, then we will log the error decoding body, and we'll format this with the error. And then we're going to need, we'll return here for now, but we're going to need a method. Oh, this is printf. We're going to need a method to be able to serve our data as well as our status requests for HTTP, right? And I don't want to have to do that because it's a pretty, you know, kind of lengthy process. So what I can actually do is inside of my server context, I'll zoom in here for you. We can actually define a new method, and I'll call this serve response, right? Serve response. And what this is going to do is JSON marshal any kind of value that we put in. Interface is a typeless type. So, you know, when you think of variables in Python, that's how you reference it in here, right? These should only be used in very, very specific cases, like now, because JSON marshal can marshal any kind of property, whether it's an integer, string, an object. It can do anything, right? And then we will log current bottom, right? So what this serve response does is we pass in the status code, we pass in the value that we want to return, and it will take care of the rest, right? So when we go into our endpoint, all I can do is reference the context and say serve JSON, right, or serve response, and say this is going to be a status bad request because that was bad data, and we're going to give it the error as a string. Oops, error. Bam. So cool. So now we've handled actually getting the data from the post body, and now we actually want to save this information, right? Now, you might have noticed we don't have an implementation for this, but that's fine for now. So we want to call our form.validate because we know that's one of the methods we already declared. Put that as another error. We'll copy this, put it down here again, and we'll say error validating, and then we'll return that error and respond again, bad request, because it was bad data. We don't want that. Now we can actually save the data. So we'll say error equals c.store, right? So this is the interface that we declared. And if you see, we already have a couple of methods that pop up. So we can say, oops, we want to save this, save form, and we want to pass in that form. Let's see. It's throwing an error here for some reason. Can I use form? Okay, we'll handle that in a second. So we don't have an implementation for the save form yet, but we can already call this, right? And if we want to handle this error, we can do that too without having to implement it. Now, this is where an interface really kind of hits home because we don't have anything implemented, but my code knows that it's going to have a save form method, and it's going to save this form, or it's going to return an error, okay? So now we can actually get to the hard implementation of creating this store. So inside of our store, right, we want to keep this packaged up so all of our data store files are all together. And we will call this Sheets because this is our Sheets data store for Google Sheets. We will create a single file called Sheets. And let's see, what are we going to have in here? So inside of our Sheets folder, we're going to have all of our methods that initialize the interface for the Sheets object, and then handle some kind of like smaller methods that we know are going to be used throughout all of the Sheets and transactions, right? So let's take a second and look at what a Google Sheet looks like, right? So we have our two-dimensional array with our labels up here, and we have two forms or two sheets inside of this document. You can think of each one of these sheets as a different collection or a different table. So you know, when you go and you do a Mongo store or a SQL store, you want to have each folder or each file specific to one category of methods, right? That makes it very easy to read later and know where some things are coming from. And the nice thing about this is if you wanted to, because of this interface, you could have some of your data store methods in one database and some data store methods in a different one. So you could use SQL and Mongo in the same one, but have very, very minimal code. The only code difference is the actual implementation of SQL and Mongo, right? You don't have to change the rest of your code. It stays the same, and it makes it really easy for avoiding conflicts and for people to kind of come in and start just implementing right away. So inside of the sheets, we're going to need a bunch of stuff, right? So I'm just going to paste all of this in. We're going to define our sheet ID. The sheet ID is just a little, the path up here. I'll zoom in again. Our sheet response, this is what's returned from Google, is what we talked about, our two-dimensional array, our major dimension, which is what we want the first set of the array to look like. So in most cases, this is just going to be row. So each row is its own object. If you wanted columns, you could do that too, where each column is its own set of objects. And these array would essentially be flipped, right? I think rows is a little easier to read and definitely a lot easier to work with. So we're going to just stick with that for now. Inside of our actual sheet object, we're going to have the sheet ID, and this is the sheet that we're referring to. And we're going to have our sheet, which is the entire sheet itself as a whole, our start range that we want to read or write from, stop range that we want to read or write from, and then the client to actually make those requests. We can then declare a new sheet method. We'll call this store. There we go. We'll import our settings. Where is it? So these are the environment variables that we declared in the beginning, right? So these are where the sensitive information is being used and need to keep secret, right? So if anybody were to see this file, all of you guys watching it right now, this would be all the private information, the stuff that I can't let get out, but because it's hidden behind the environment variables, nobody has to worry about that. We'll pass in a new context right here so we can track that separately. Are there any questions so far? Will it be uploaded on YouTube? Oh, I'm pretty sure they're recording. Yeah, it says recording up in the top right. Yeah, so I would assume it'll be on YouTube. I'm going over a lot right now, so I'm sure watching it back again, you'll probably absorb a little bit more. So, okay, so it says it's throwing an error here. And why is it throwing an error? It's because we have a sheet and we're trying to return our sheet object up here as a store interface. Now you might be thinking, wait a minute, this is a typed language. How on earth can you do that? Well, the interface is not an object. It kind of wraps around the object that you give it, right? So in this case, I want to give the sheet the methods of store, okay? So in order to actually get rid of this error, I need to implement those two methods from our store, these two right here. I'll zoom in so you guys can see. I'll copy these two so we can use those in a second. So going back to our sheets folder, we are going to have a single sheet to deal with the forms. So we want to have a single file to deal with the forms, and we'll call that forms. So inside of our forms file, we're going to first establish a constant of what the name of the sheet is, and in this case, it's going to be forms, right? That's the sheet name on the bottom right here. And then we want to start implementing our sheet methods, right? So first, where'd it go? Here we go. We will copy these two, go in here, and we'll start making these a methods of the sheet object. So we can do sheet receiver, and this will be a sheet like that. Give it an end, and then this should auto import. Cool. So now we have, and we'll just return nil for both of these for now. Nil and comma nil. There we go. And return nil here. So now that we have these two methods implemented, if we go back to our sheets, why is it still erroring? What do we get? Need method have, let's see, store. All right, let's see what we got here. I think these are implemented wrong. These are form. Inside of our store, we'll go back here. Oh, this is the wrong one. There we go. Oh, hang on. Auto importing is kind of weird sometimes. There we go. Okay, so now we have the right package that we're importing for entities, and the error went away. So now we can successfully return back our sheet, and I'll zoom in for you. We can return our sheet object as a store interface. Okay, so now that we actually have somewhat of an implementation for that, we can go into our context where we're supposed to initialize our store up here. Zoom in a little more. There we go. Supposed to initialize our store so that way we can use it inside of our endpoint, which we are calling right here. Inside of the server context, we need to start initializing our store. Okay. Let me. So we will call our sheets library because we just declared the sheets as our hard implementation. This is what we're going to be using. Let's make sure that package is right. Yes. We want to be using sheets here instead of Mongo or SQL or anything. So we're going to call sheets.newSheets. And this is where the implementation would change based off of if we want to do SQL, Mongo, or Google Sheets. Let's see, does this work on a local server or it can be visible on the internet? Yes, we'll run it in a second. So you can see it working on my local, and then I'll deploy it, and I already have a deployed application. So that way, you guys can kind of go check it out and actually interact with the data real time. Is Google Sheets fast enough for most applications? Yes, they have some methods to speed things up a little bit. But for the purpose of this, we're just going to be doing their basic append method and their basic read method. But that is a good question because referencing a two-dimensional array can get kind of slow sometimes. So okay, so now inside of our sheets, we actually need to make the request to sheets because we haven't done that yet. So we're going to first declare an append method, right? Because there's each sheets API service requires a different set based off of what you're trying to do. So for append, we would use post. For writes, we do puts. Reads, we do gets. You know how it is. Let's import these. There we go. Bytes.newReader. Make request, we'll implement that in a second, and then we'll do JSON Marshall. URL parse is our URL library parse, and then build URL. So we'll build that in a second. So what this is doing is when we call append request, this goes through and takes our payload with our interface, and all it does is just insert it into Sheets and just tells me if it worked or not. If it didn't work, I can discard it, return back application saying this didn't work, or it'll return nil. I'll be like, okay, cool, we're good here. But we need to build the URL, which is a little bit. I'm just going to import all of these libraries real quick. Go up. All right. So we need to build the URL because the URL can get pretty crazy. So you can read this by going into the docs. You call the Sheets APIs. You have to enable it through Google. Oh, let me zoom in. Keep forgetting. You can initialize it by calling Google APIs and then by passing in a couple of formatting. So this is the sheet ID. This is what we declared up at the top. Our sheet, we want to be referencing the forms sheet instead of the actual OfferUp sheet this time. And then we'll have the start range. If there is a stop range, then we'll add it to the URL. And then we'll give it our API key and then say user entered, so that way we can imitate a user to make this happen. Now we need to actually make the request. I will input the make request method. What this does is it takes in a request that we initialized in the beginning, right? So we'll initialize our request object. We'll say we want this method post. We already built the URL. We already marshaled the payload. We want to put that in the body, and we just want to say make this request. And it says, OK, I'm going to do that. And it does some stuff to make the request. Use the HTTP client, and then just does some standard Go HTTP requests. So let's see. Do we need anything else to actually be able to implement our store method? I don't think so. So let's actually implement this save form. So with our save form, the methods that we declared earlier to convert it from a form object to a list of strings is going to come in handy here. But first, we need to do a couple of setups. So we need to set the sheet to our form sheet that we declared up at the top. Form sheet, there we go. We'll set the start range to A2, because when you go to Google Sheets, I want the titles to stay there. So that's why we declare, A, cell A, or column A, cell 2. And then we'll start the request from here and then work our way down. Save, and then we'll do sheet. So we want the stop range to be append, so we can start loading up new things. And then we need to actually declare our update request, give it a sheet response. Now, this is where we pass in the two-dimensional array, and we call form.toList. This will take the object, return back a list of strings, and this is the hard implementation of interacting with the database that we have initialized already, right? So my endpoint doesn't care about all of this. It's just hoping that there's a method at the end of this that does what it needs to, and if it doesn't, it's going to return back an error. Okay. And then instead of returning nil, we will say s.do append. Oh, wait a minute. Let's go back here. Append request sheet. This is supposed to be sheet response. Go back. Where's that? We're going to close some of these. Server context, we don't need that. Index, we went over that. Store, we can close this. Main, we'll keep that open for now. And here we go. OK, so return sheet do append request, and we'll pass in the payload, which is update. Bam. So you see the error went away. We do the append request, and we actually save the form. So now inside of our endpoints, when we call this save form, it will work with the Google Sheets implementation, right? So this is where we kind of like really hit home about the architecture of how all of this kind of fits together. And then at the end, we'll just serve the response as status OK, and we'll give it OK. Cool. So let's see if it's actually runs. Didn't give me an error for some reason. Let's run the front end. And this will pop up a new window. Oh, it didn't run because we don't have anything in our main. Duh. So let's do that while we're waiting. There's our front end that we just established. We can put some info validation in there. You can see since we put that type email, it's going to give us, I'll zoom in a little bit so you guys can see. It will throw an error because it's not an email. We'll give a search, radius, minimum, maximum. And then when we try to click this submit, that notification will drop down saying, please enter your search. So inside of main, I'm just going to copy and paste all of this for the sake of time. Points, server context, boom. We don't have a get form method, so we're not going to do that yet. And then we need to import our HTTP package, blog package, and then our webcraft. Alrighty, as well as our settings. So we need to import settings.port. Our file server, we need to get rid of that. And let's see if that runs this time. There we go. So now we're running. So if we go back over here, we see one, a little test object right there. If we want to put in Anna at Addigy.com, search, we'll do motorcycles, radius of 50 miles, min price $1,000, and we'll do $10,000. Submit. Thank you. It says we're good. We go back in here, and then there is our data that just showed up, and it went through our entire backend. So now we need one last thing, just a little cherry on top. I would want, if I had more time, I could go and implement the get form method. That will be in the GitHub repo, which I can drop for you guys to look at later. But we need a deployment script, because that is the bane of most developers' existence, is once you make your changes or someone else makes your changes, you have to go and actually deploy this to development or production, and that can take quite a bit sometimes. So first we need to declare a bash script. We're gonna do this real quick. We'll call this deploy, deploy, we'll rename that. Still working. Rename to grammarly correct. And then there's a couple of things, right? So we already have our app.yaml, right? And this is our G-Cloud configuration. We need to actually authenticate. So we have our service account that I'll zoom in. We have our service account right here, organic ViewVac. This is just generated automatically. This does the authentication for who can deploy this. Each person has to have their own service account, so that way our DevOps team can start handling permissions and security accordingly. We set the configuration project to our defaultly generated production. We run npm build, which compiles all the assets. We do npm run prod, which puts all of these assets and minifies them, so that way we get a small couple of files as a distributable, and then we run the G-Cloud app deploy. So let's run that deployment script and see if that works. So are there any questions? Because we're about finished. We have 2 minutes left. So the nicest thing about Go and Vue is when you do go to compile this, it is the easiest thing to actually deploy, because when Go compiles, it compiles into a single binary that includes all of its libraries, all of its dependencies, and all the code generation, and is a single executable and doesn't require any setup script. It doesn't require any environments unless you're running environment variables, no Docker containers. It's just an executable, you put it anywhere. With Vue, it follows the same format. So when you compile it, you get a single HTML file, you get a single JavaScript file, and a single style file, and that's it. So if you take those 4 things, you can put it on any single computer running any operating system, and it will still run your server, which gets rid of all the, the versioning problems, the setup old OSs that is a pain sometimes. and it just makes things a lot easier. So we're going through, it says upload done. It's already been deployed once before, so I will, let's see, I'll wait for this to finish. It should be pretty quick. I'll drop the link for the GitHub repo, so that way you guys can take a look at it, and I have my resources down here in the bottom. So if you want to contact me, ask me any questions, send me an email at jake@Addigy. The Sheets API is in here. This is the GitHub repo, so I'll drop this in the chat right now. And then the actual app that you can go to and actually mess around with. You can interact with this data in the forms. You can interact with the DB. This has the GET requests. This has the save form requests, and you guys can just kind of go wild. Splitting the service traffic. So yep, that's pretty much it for my implementation. We had to go really fast because there's a lot to cover, but we went from the initial idea of we want to build an OfferUp notification platform, built the front end, configured it, built the back end, went through, this is completely production ready. So if I were to bring on 10 new people tomorrow and I say, okay, these are the entities, these are the store methods, these are the endpoints, they're going to look at these and be like, got it, no problem. It'll be really easy to kind of onboard new engineers and kind of elaborate more on different features, fix bugs. This is a really nice platform. And you can see this is publicly accessible. I'll drop this in the chat as well. So you guys can actually start interacting with this, and this still does all of its validation and whatnot. So that's my talk. Thank you very much. Do we have any more questions before I log off? I will give it to 10:03 in the meantime. So let's see if this works. jake@addigy.com. We'll do iPhones. The best workshops. Thank you. Thanks, guys. I'm glad you learned something. I really encourage you guys to look. There are a ton of videos on YouTube about doing Go applications. You can use them for anything. It's as versatile as Python, except it's typed, but not over dramatically typed, like Java or C or C++ might be. So it has the readability, going through the endpoints. This is fairly easy to read. Form validate, save form, serve response. This is pretty straightforward, and it's also incredibly lightweight and really good for a lot of multi-threaded applications. So thank you very much, guys. Keep hacking away.